Okay, so once again, we're still experimenting with the equipment problem we have using the webcaster onto YouTube. It's a problem that arose about a month ago. Thought we had it resolved yesterday. YouTube is so difficult to work with. They change things, procedures, sometimes in compliance with lawsuits and the like, and they don't care what effect it has upon the people that they rely upon for generating their income. And so I don't know why this is now streaming after trying to play with it for half an hour, and I dread having to use this in class. Anyway, this is going to therefore be a much amended introduction to Econ 136, because at least I can get this posted. And the intent here is not to give you the opening lecture for Econ 136 spring of 2020. The intent is to give you some background information to make sure that you're prepared for the course and are actually qualified to take this course, because this course has a much higher bar for admission than does, say, Econ 104. Any student from the Claremont colleges really can qualify to get into Econ 104, but that is not the case for this class. And so before the class starts, I want to make sure that everyone understands that. So let's talk a little bit about where we're going here. Okay, now as the prerequisites point out, you have to have taken Econ 104 at Harvey Mudd or the equivalent elsewhere, such as the Corp Finance course at CMC. I do rely upon your knowledge of the background material you already know in Econ 104. I'm not going to go back and explain how put and call options work or how futures contracts work. You're going to have to already know that going into this class. And to review that, of course, you can at least go back to the chapter I wrote for those texts, or the text I wrote, I should say, for those subjects, the chapter on options and the chapter on futures, to review that. But once we get into, for example, the discussion of settlement on futures, I'm not going to explain the background. I expect you to understand how that works, because otherwise I'll never get through this class. Now, the class, as I said, has kind of high admission standards, and so to give you a sense of that, I had to perm in a lot of students in this class, and I got way more perm applications than I was able to accept. So the standard I'd use on perms was to go back and check the previous Econ 104 grade, and I only let in students who got an A in the Econ 104 class, not even an A-, and I certainly did not admit any students who took the course pass-fail. My intent was to have the registrar only enroll 10 students in the original course. In fact, I thought that was the instructions I gave them, and I was going to perm in the other 40 using this standard. Because in the past I discovered that everybody's enthusiastic about this subject, but not everybody's willing to do the work that I ask to complete the course. A lot of students slack off, and then that causes a problem for me, and I deny admission to other students who would have worked harder. So I set the bar pretty high on getting into this class. So please commit to working in this class if you're going to sign up for it. It's not really like the other classes I teach where you can kind of slide by and get a passing grade. If you're not from Harvey Mudd, then you need to have a deep knowledge of math. It's as simple as that. If you're from Mudd, you already do, if you're past at least a sophomore year, so that's not a problem. You need to understand or have seen or used applications of differential equations. We use the same differential equations over and over again, so it's not as though this is a course on applied differential equations in finance. But you do need to know what we're doing when we use those. And this class even uses stochastic calculus, although I know that there's probably not a single student who's ever taken a course in stochastic calculus, so it's not required that you've been exposed to it prior to the class. I show you enough about how it's being used for us to use it in the derivation, for example, of options pricing models. But you really need to be very, very comfortable in the world of math, and you need to be comfortable in the world of math for my examinations. And so if you're coming from a school where you don't have that kind of background, you have no business being in this class. You also have to be very comfortable with programming in Python 3 And you can't use other languages as a substitute in this class, like MATLAB, for example. And you should either already know NumPy and Pandas as an extension of the big libraries that have a specific purpose for Python 3, or you need to be willing to use it learn it, I should say, very quickly. You need to go out there and take a look at some YouTube videos introducing yourselves to NumPy or to Pandas, because we use it extensively here and I don't bother to explain it. You have to be ready to use it on the fly. Now you can learn it, by the way, quickly from YouTube and the like if you haven't had exposure to it before. You will have to use a good editor or IDE, and I don't restrict that to any specific editor or IDE. Use whatever you want or you're comfortable with. I'll say a little bit more about that on the next slide. But you do have to be set up to use Jupyter, or you're going to find it a little difficult to proceed in this course without the ability to use Jupyter, because I pass on a lot to you in the form of Jupyter IPYNB files or HTML files where you can copy and paste them easily over to Jupyter. I use Jupyter a lot. It's really good for instructional purposes, and it's a good editor for you to use when you're working on a team environment. I strongly recommend, even if you haven't done this yet, that you download Anaconda as your primary Python source. Just go to the Anaconda website and read a little bit about what they offer, and then download their most advanced version for a 64-bit machine of whatever they're downloading in Python right now, which will either be, I think, about 3.8 or maybe even 3.9. I'm not even sure that 3.9 has come out yet. There's a reason for this recommendation. It really allows you to integrate all the stuff we're using here. This does allow you to set up a virtual environment. And if you set up a virtual environment, that means you don't have to take older copies of Python or even Python 2 off of your laptop if it's sitting there now. You can overload the Anaconda setup right on top of, say, Python 3.6 and Python 2.7, and can use them interchangeably so long as you set up a virtual environment when you download Anaconda and Anaconda Navigator. That may sound formidable to you, but it's really easy to set up an environment, and it's really something you should do for the future anyway, because I use them and it seems to me that they're likely to be used in team environments professionally when you go out there to get your job. They're so much easier to control versions of things. One of the primary advantages of the environment is it does allow you to go back and fix old code, say in Python 2.7 or some older version of Python 2, and at the same time write new code in, say, Python 3.8 on the same machine without getting things messed up or confused. Because when you set up the environment, you specify which version of Python that environment is supposed to use. And so if you're in that environment, it will use specifically the version of Python that you ask for. And so you can have, again, multiple versions of Python and other software within your coding environment. My coding environment on my primary machine, which is behind me in this photograph, is called Algos. And it's easy to set up. And don't be intimidated by the what you might perceive as the difficulty of setting it up. So I highly recommend that. You will get a very workable version of Jupyter Notebook inside of the Anaconda distribution. And it's really, really convenient and easy to use, especially on the fly. Jupyter Notebook is kind of really suitable for a certain line-by-line coding. It seems to combine the best of having an IDE and idle at the same time, because you can check each line of code as you do it, while at the same time, unlike in idle, you can also check the integrity of how all the code works together in Jupyter Notebook. And of course, it leaves behind a very readable legacy of whatever it is you've done. It's a very powerful package for managing additional libraries. Just every library that exists seems to be in Anaconda. So if you say, hey, I want to use the library called Quad, I think it is, it does brute force integration, which we will end up using here, Where do I get that library from? Well, it turns out you can conda it in directly from the navigator by just going to the navigator and saying, I want that library, and clicking on it. So the libraries in Anaconda, although you might like to use the control line interface in your terminal for everything, the Anaconda navigator is usable that way, but also usable as with a GUI, with a visual interface, which is what a lot of you are used to. So it's a great source for adding libraries, including, by the way, TensorFlow and Keras and the machine language libraries. And then, of course, it is platform independent and works very well with Windows, Mac OS, and Linux. And I use all three operating systems. I'm not using Mac OS very much because I've switched everything over to Linux, but I know that Anaconda and all of the Python variations from Anaconda work very well in any of these environments. So that's strongly recommended that you figure out how to get the Anaconda distribution onto your laptop or your computer if you have more than one. I guess I should emphasize that you need to choose a decent editor IDE. You probably already have one, so this is, especially if you're a MUD student, because you're programming in Python already if you're a MUD student. But maybe choose a second one that your teammates are likely to use. The course is going to be advertised, the course is going to be organized into, apologies for stumbling here, I haven't given a lecture now in 6 weeks, so I have to get slowly back into lecture mode, as you can see. The course is organized in such a way that we choose teams of 4, 5, or 6 to cooperate on the in-class work where we program in class. And so for that, you probably want to choose an editor or an IDE that your teammates are likely to use. I use 2 or 3 editors. And so some of the candidates are Sublime Text, which I'm currently using for most of my coding and all of my coding in a Linux environment. VS Code is, of course, very powerful and very popular. And PyCharm is favored by a minority of students who really like its full-featured capability, and it is a professional-level, full-featured IDE. It's a little heavy on the background. It's a pretty high requirement for memory use and the like. And Spider is used by a lot of people because it comes as the default IDE, or did come as the default IDE for Anaconda. Anaconda these days uses both Spider or PyCharm. It allows you to choose between them. Sublime Text does cost $80 supposedly if you buy it, but if you use it, you know they never actually ask you for the money. They just keep hinting that you owe them $80. In my case, I paid for it because it's worth it to me to spend that kind of money to have coders work so hard on what is turning out to be a really, really powerful editor. Alternatives include Notepad++. That's only for Windows, but boy, that's a nice editor for Windows. When I'm in a Windows environment, I usually use that instead of Sublime Text because it's really got a lot of useful plugins. And I use Notepad++ to also program in HTML and CSS for the same reason. Now, old programmers like me, these fossils that are fading away, need to be fading away, of course, will also be using Vim and Emacs. I'm an old Vim user. Actually, I was an old Vi user before it became Vim. Vim is a maniac's coding language that's used by people who consider it to be sacrilege to use a mouse. It's a command line based program where you're in conventional editor and all of your navigational commands are done with keystrokes. Emacs is a much more fluid and detailed and open, I think, professional level coder that's used by people in the Linux environment extensively. I know a lot of MUD graduates who are professionals use Emacs, including some who are quite famous. I use Sublime Text, by the way, because it incorporates almost all of the Vim commands. Sublime Text actually is basically Vim with a GUI interface. And if you don't believe that, go take a look at the hotkey commands for Sublime text, this enormous list of hotkey commands. And what you're looking at there are simply the control keys that are used for Vim for the largest part. And so Sublime Text allows me to go back and use my old Vim habits if I want to, but also to use a mouse if I feel like doing that, with all of the ability to get the color coding text and all of that. So you can use something other than these, of course, but put some thought into it because you'll be working with your teammates with this. So this is running programs, by the way, that you and your teammates write under the pressure of an online exam. Now, the reason I stress this is that some of this coding may have to be done when you're taking an online exam, and certainly the execution of your existing code will have to be done when taking an online exam. I'm asking you, in some cases, to create a program that does this. I give you some guidance, I give you some sample code, and we test it out in class by example. But when it comes time for exam, I say, well, what if we suspend our belief that an alpha should never be included in an options pricing model, and we use an estimated alpha? What impact does that have upon the call price and the put price for this specific option? The only way you can answer that is to run custom created code that we created in this class, because there's no commercial code that I know of that does that. And so therefore these programs have to work, and so you want to choose an editor that's easy to work, or you can rely upon, I should say, in the online exam context. You do have to bring a code-capable laptop to class every session. Attendance in this class, unlike my other big classes, is mandatory. Econ 104, Econ 53, those classes all recorded on video. I don't care whether you attend the class or not. This one is different. None of the lectures are recorded on video. There is a lot of video like this for the class, but nothing that is recorded in class. I require you to come to every class, and I try to have a method where I can figure out whether you are. Last semester, you may recall, I was trying to write a machine learning in Keras based upon one that someone else had done. I had to abandon it because it was taking too much time, and I need to be coding my models, not that. But I'll figure out a way to take attendance in this class, and it is mandatory, so you've got to have a good laptop so you can work on this stuff, or take notes, depending on what we do on any given day. What we do, fortunately, is platform independent. I say mostly, and the reason I say mostly is that some of the material I give you has a path command in it that's specifically a path command for either Linux or for Windows, and so you got to figure out how to put in the equivalent path command for whatever it is you're doing, given whatever operating system you have. So we'll have a little sub-lecture on how to do that. And that's the only sense in which this is platform dependent. And you do want to be able to code in Python on the fly. Now, everything else I'm going to tell you about is going to be covered in the opening lecture. You know, how I'm going to give grades and what I expect of you and the course outline. I still haven't prepared the order of the material that I plan to present in the course, and this is actually the day before the course is scheduled to begin, but I know how it's going to open, and that's all we need to worry about right now. So good luck, and let's do something useful in this class. This class really has what I think is a pragmatic orientation, where you can literally walk away with usable models, or the beginning of usable models that are prepared, in my opinion, at a very advanced level. So I'm really looking forward to this class. This will be the last time I ever teach it. I plan to convert all of this into my own research for investing during my retirement years, using algorithms for that. And so this will be my last chance to present this material in material other than video to the students in the class. So we'll see you tomorrow, or maybe I've already seen you by the time you watch this video. And I'm going to meanwhile try to iron out these damned YouTube video recording problems. These seem to have risen when the issue of like videos for children, the COPPA issue, popped up about a month ago or so. But maybe that was just coincidence. Okay, we'll see you in class.